Morning, everyone. Hope you're all doing good. Let's take a look at one of our first lessons of the year, solving systems of linear equations. It is some things that you should already know, so it's a little bit of a review for you because we're going to build on that in upcoming lessons. The different ways that we could solve linear equations, we know we can graph it, solve it that way. We have substitution, and we have elimination, which is also known as linear combinations. So those are the three ways that you have learned how to solve systems of linear equations, and we're just going to kind of review that a little bit, getting us ready for some later lessons. So if you take a look at the solving systems, I would say you could probably go split screen watching this and then split screen of the actual notes while you're doing this on Notability is probably your best bet to be able to do both at the same time. So if we look at number one, solve by graphing. Both of them are already in slope-intercept form. So if we remember, y equals mx plus b is our slope-intercept form. And our slope is that number in front of the x, so that's your rise over run. And then your b is going to be your y-intercept. So to graph this first one, you go to where 0, -1 is, and then it has a slope of 4/3, which is rise 4 and to the right 3. So up 1, 2, 3, 4, over 1, 2, 3. Do it again, 1, 2, 3, 4, over 1, 2, 3, and that pattern would continue. We would go in the opposite direction, going down 4 and to the left 3. So 1, 2, 3, 4, over to the left, 1, 2, 3, down 4, 1, 2, 3, 4, and over to the left 3. We would connect those dots all the way through and include arrows. If we take a look at the second line, we know the slope, because it's already in slope-intercept form, is the number that's in front, so the -2, and then the y-intercept is the +9. So that's telling you that you're starting at 0, 9, and then the slope of -2 means down 2 and to the right 1. So you would continue that pattern all the way through, down 2 over 1, down 2 over 1. Use a straight line to connect them. Include your arrows. And then the whole question here says solve each system. So we want to know, what is the solution? The solution is where those two lines intersect. So if we look right there, it's at the point 3, 3. So our solution is 3, 3. That's saying that that point is true for both of those lines. If you plug in 3 for x, 3 in for y, they both check out. If you take a look at B, the top one is in slope-intercept form. Slope is 5 over 4. Y-intercept is 5. So if you're starting at 5 and you're going up 5 to the right 4, down 5 and over 4, and that would continue. Connect the dots, straight line, and include arrows. If we look at the second one, that's in standard form. So a lot of times we learned that to be something called the cover-up method. So the cover-up method, instead of putting that into slope-intercept form, if I cover up, in this case, my y's, I have this statement that says 10x equals -40. So if I divide both sides by 10, I'm getting x to be -4. If I now cover up my x, I'm getting negative 8y equals negative 40. Divide both sides by negative 8, and you're getting y equals 5. So what that's actually doing is finding the x-intercept and then the y-intercept. So the x-intercept, negative 4, is right here, and the y-intercept, y equals 5, is saying 0, 5. And if you look, those are the exact points that we already had. Connect them, it's the exact same line. So our solution can be said one of two different ways that I would accept. The actual solution is all points on the line, and then you could actually give either of our original equations. So y equals 5/4 x plus 5, or you could have given the line 10x minus 8y equals negative 40. I would say go more towards slope-intercept form answer. It also means if we were saying how many solutions there are, it would be infinitely many solutions. So that's something that comes up too. When it's the exact same line, you have infinitely many number of solutions, but that means it's the same line. If we go into solving by algebra, that leaves us either substitution or elimination. And you could go any way you want, whatever's easiest for you. You should have to know how to do both of them for sure. If we look at number 2a, because I have a y all by itself, I think substitution is probably the best. So since y is equal to this whole thing, I substitute in to the other equation where the y is. So if I look at my original from up top here, I have a 4x plus y, but I'm going to be putting something in place of y, and then equals 11. Well, what am I putting in its place? This whole thing of negative 3x plus 9. So then if I combine like terms and solve, I have a 4x plus a negative 3x, which is a positive 1x. Then I have a plus 9 equals 11. Subtract 9 from both sides, and you're getting x equals 2. Now that I know x equals 2, I want to find what y is. So I would take that value and substitute in for x into either of the equations. The second equation, since the y is already by itself, that's probably the easiest, but both work. So y equals negative 3 times x, but x is 2, and then plus 9. So y equals negative 6 plus 9. Negative 6 plus 9 is a positive 3. So I have an x value of 2, a y value of 3. So my solution to this system is the 0.23. So make sure you actually give that value and not just x equals 2, y equals 3. It's an ordered pair. That point is what the solution to that system is. If we go on to 2b, we could solve it any way we want, but I think most likely using elimination is the best bet. So we need to get either the x's to be exact opposites of each other or the y's to be exact opposites of each other. It doesn't matter what. But if I look at this top one, if I multiply that whole equation by a negative 2, I'm going to have a negative 2 times a 2x, which is negative 4x, which will be the exact opposite of the second line that has a positive 4x. So then I would eliminate the x's. And don't forget that that negative 2 gets distributed to all three of those terms. So my new equation here would be negative 4x minus 6y, and then equals negative 8. I didn't change anything on the second equation, so I just repeat that. 4x plus 2y equals 12. Now, in order to eliminate, we want to add the two equations. So a negative 4x right here plus a positive 4x gives you 0. Then a negative 6y plus a 2y gives a negative 4y. And then negative 8 plus a 12 is a positive 4. Negative 4y equals 4. Divide both sides by negative 4, and you're getting y equals negative 1. Once you get that value, you substitute in for y, either right here or right here. Doesn't seem like one is easier than the other in this case, not sure. I'll just pick the top one, the original, because they're smaller numbers, we'll say, but it really doesn't matter. 2x plus 3y, but y is negative 1, equals 4. So I have a 2x minus 3 equals 4. Add 3 to both sides. 2x is 7. Divide by 2, and you're getting x equals 7.5, or 7 halves, or 3.5. I'm fine with fractions, so our final solution is 7 halves, negative 1. Going to have you pause the video, solve C and D, solve them by any algebraic way that you want. I'm going to post the answer in just a second, so make sure you do pause it. Check your answer. You can always chime back into Zoom if you have a question on any of these, but solve these two and then we'll move on. When you solve C, you should be getting no real solution. That's saying when you went to solve, you ended up getting something that was a false statement. I believe you got something like 4 equals 7. That's not true, so that's why you got no real solution. When you solve D, you should be getting all points on the line, and then you can give either of the equations. If you write it in kind of a standard form or slope-intercept, I would probably go with the bottom one and write it like this. And remember, when you're getting all points on a line, it's actually saying infinitely many solutions. That's how many there are. Let's take a look at number 3 together. Bringing in some old geometry type things here. Length of a rectangle is 2 centimeters more than 4 times the width. If the perimeter of the rectangle is 34 centimeters, what are the dimensions of the rectangle? Write a system of linear equations and solve. There's a whole lot of information there. One thing that I would say is, let's label the width to be W, and let's say the length would be L. So if I actually draw in a rectangle and I break down each sentence, it says the length of a rectangle, so L, is 2 centimeters more than 4 times the width. So our length here is 2 centimeters more than 4 times the width. So we're thinking two plus 4W. That was weird that didn't show up. And then we have our width right there. the perimeter is 34 centimeters. That means you add up all of the sides. Well, how do you add up all the sides? You have two W's and then two L's. So our system of equations here would be L equals 2 plus 4W. And then we have twice the width plus twice the length is equal to 34. So if we're actually going to solve this, I think substitution is the best because you have an L all by itself and plug that in right there. So you're getting 2W plus equals 34. Well, what is that blank? It's a 2 plus 4W. So you plug that in. Combine like terms. 2W plus 4W is 6W. I have a plus 2 equals 34. Subtract 2 from both sides. And then divide by 6. (32 divided by 6). Let's see, did we mess something up here? Yes. When we're substituting in, this was 2L, so it's 2 times 2 plus 4W equals 34. So that 2 would end up getting distributed to each of those. So 2W plus 4 plus 8W equals 34. Combine like terms. 10W plus 4 equals 34. Subtract the 4, and you're getting 10W equals 30. So W equals 3. This side is 3. Substitute 3 in for our W right there to find what the length is. So it's 2 plus 4 times 3. So 2 plus 12 is 14. So our answer would be width is 3 centimeters and length is 14 centimeters. Taking a look at the last one here, I'll give some hints. I want you to solve it on your own. Let D be dimes, N be nickels, and then remember that a dime is 10 cents. So that's 0.1. And then nickels are 5 cents, so that's 0.05. So that's just a little hint. I want you to solve it right now. Pause, because I'm going to give the solution in a second. So if you solved it correctly, you should figure out that Chris has 53 dimes and 14 nickels. So make sure you finish completing the rest of the stuff that I had told you to do, and then we'll see you real soon.